Now to connect the 101 sequence detector on the trainer board, we'll need two D flip-flops. We can call them the flip-flop 0, flip-flop 1. We'll also need one input or one switch called X, one output which is going to be an LED, and we'll call it Y. So let's label things on the trainer board. X is going to be a switch. Next, the output will be Y, which will be just one of the LEDs. We'll need two flip-flops. We can call them FF0 and FF1, flip-flop 0, flip-flop 1. Before we start with the connection, we'll first make sure that the clocks of the two flip-flops are connected together to one of the clocks on the trainer board. Now we're ready to make the rest of the connections. We have X as D0. D0 is equal to X, so this connection is complete. Now we need to connect D1. D1 is the output of two input OR gates, where the first input is Q1 and Q0 bar and X. So we'll need to use a 3-input AND gate that takes Q1. This is Q1, it's the top output of flip-flop 1, and Q0 bar, which is the second output of flip-flop 0. This is Q0 bar, and X, which is the switch. Now there is an open input for the 4-input AND. We don't need to use that input, so we'll connect it to a constant one, which is just the 5 volts on the trainer board. Next, we'll connect a 2-input AND gate that takes Q0 and X bar. So we need Q0, which is the top output of flip-flop 0, ANDed with X bar. We only have X. To get X bar, we need to use one of the inverters on the trainer board. So we'll connect X to the input of the NOT gate. The output of the NOT gate now is X bar, which will be ANDed with Q0. So we'll connect a wire from X bar to this AND gate. Now we'll take the output of the first AND gate, the 4-input AND gate, with the 2-input AND gate, and we'll OR them together. So this is the 4-input AND. We'll take the wire from its output and OR it with the output of the first AND gate here. The output of this OR gate gives us now D1, so we can connect it directly to D1. Now the last thing we need to do is to connect the output, which is equal to Q1 and Q0. So we'll take a wire from Q1, which is going to be this pink wire. This is Q1. And we'll take a wire from Q0. Q0 is this black wire. So we took a copy from Q0 along with a copy from Q1 like that. Now this is Q0 ANDed with Q1. The output is going to be Y. So we'll take a wire from here connected to Y. Now the connection is complete, but again, to test the circuit, it's important that we can that we know the moment the clock rises from low to high. So we'll need a way to monitor the clock. So we'll connect a wire from the clock, any pins, either this one, or this one, and we'll connect it to one of the LEDs, which was the last one. This way, we'll make sure that while the clock is off, we'll change X to 1. When it rises between, or when it changes between low to high, that is the moment it's going to read our input, or which is 1 bit of the sequence. So we're going to enter 101, 1 bit at a time, every time the clock has a low edge. The output Y will change to high once the complete sequence has been detected.